Thank you everyone, and welcome to our presentation, which we're going to be talking about unlocking developer potential in regulated environments. So Summit's a great place to come and learn about some of the amazing new products and services that Amazon has been delivering. But for this session, we'd like to switch gears a little bit and maybe talk to you about some of our experiences using these products and services to solve real-world problems. But before I begin, let me introduce myself. My name is Donaldson. I am a senior consultant here with Sourced, based here in Singapore. And I'm joined here on stage by my good friend and colleague, Kevin Littlejohn, also a senior consultant based here in Singapore. I'll also take just a few moments to introduce Sourced. So Sourced was founded nearly 10 years ago in Sydney in 2009. And we expanded into the North American market fairly soon after. We've been working with some of the largest brands in both Australia and Canada over that time. And we found that our experiences can lead to some very common solution patterns and also some very specific solution patterns. Our goal as a consultancy is to work with 25% of the top 200 FSIs in the world to assist them on their cloud journey. About nearly 2 years ago, we expanded into Singapore, and in that time, we've been working with some of Singapore's best-known brands and highly regulated local organizations to help them on their cloud journey. So today, we'd like to present to you 3 learnings, and we're presenting you our learnings based on our experiences with large regulated organizations. But before we get into the patterns, I just want to take a moment and just think about the particular challenges that face regulated organizations or regulated entities. So one of the particular things about it being a regulated entity is that often means you're a large organization. You might have many thousands of employees. So that presents a particular challenge when you're attempting to implement a pattern. You might have a pattern that's come out of a small or a medium enterprise and might work very well there. But when the time comes to scale that out to an entire organization, well, you might find that that's not so efficient or doesn't work so well. Secondly, for a regulated entity, compliance is everything. You always have to keep compliance at the top of your mind when you're attempting to roll out such patterns to regulated organizations. So the desire is always to make our developers as productive as possible. But we also have an obligation to our compliance, to our auditors, to demonstrate that our PII data, our PCI data, our other sensitive information is adequately protected. And finally, cost control. So anytime you're attempting to roll out a pattern at scale, across your whole organization, cost management has to be baked in from the very start. So let's talk about how we put people on a path to success with their cloud journey. So there's a really great talk coming up this afternoon from our friends at NAB, National Australia Bank, who are going to be talking about training. And we all know that training is an essential component of success. But what we know from our experiences, another important component of success alongside training is a strong culture of self-directed learning. And we know that's a really important marker of cloud maturity. When your people are on a self-guided path to discovery and to upskill, we know that's a sign of an organization that has strong cloud maturity. So what can we do to help with that? We want to enable people to do self-directed learning at scale, but in a secure and a compliant manner. So we have some special challenges in this regard. As I said before, for a regulated organization, the security and compliance baselines have to be met, and the approach has to be scalable from just a few users to hundreds or thousands of users. So let's take some time to think about the considerations when we're enabling this self-directed learning pattern. So the first thing I'd like to call out is this idea of self-service. And there are 2 really important parts to self-service. In an organization, a large organization, you might find that you have a small number of highly competent, highly skilled cloud engineers, and then you have a larger teams who are attempting to consume cloud services. And what you don't want to happen is for that small team to become bottlenecked or overloaded with requests to service or upskill the larger parts of the organization. So if you're building a strong self-service capability, you can ensure that your teams are not becoming bottlenecks in your cloud journeys. And second reason self-service is important is automation. So self-service and automation go hand in hand. Automation helps us achieve a consistent result. So when we're enabling self-service through automation, what we want to do is bake in those compliance elements into the automation, into the self-service itself. So to meet our audit and compliance goals, we need to show that we're not only applying appropriate controls, but that we're applying them consistently. And of course, if we want to scale this out to hundreds or even thousands of users, we also want to bake in cost management, because if we have a small inefficiency, you multiply that by 10,000 people, and that's a large inefficiency. And of course, let's not forget that we're here to encourage learning. We want to encourage people to learn, to grow, to take ownership of their own cloud journey. So let's talk about building up an environment that's suitable for self-directed learning. I would think we just heard like a great talk from Standard Chartered now, who talk about their standardized patterns for accounts, for building up accounts. So we're talking about a process similar to that. So this is just a generic process where we're going to take an account, we're going to bake in some networking, some appropriate networking and direct connect, and we're going to layer on top our identity and access management, which is going to federate back to our corporate identity provider. Now, depending on where you are in your cloud journey, you may already have an account engine, or you might be looking at building one. And that's what's going to add on these additional layers. So we want to have continuous compliance using Amazon tooling such as service control policies, config rules, cloud trial guard duty, and so forth. And for monitoring, we want to have that as a standard part of our account baseline. So we want to have CloudWatch in there, or a third-party monitoring tool. So right now, this is a standard account baseline. Obviously, there's a lot of detail we could go into, but what we're interested in is the process by which we build this account structure. So we could take this and we could hand it. We could hand it to a development team and say, start your learning, start your exercises, start your experimentation. And at this point in time, I would want to mention some of the fantastic new products coming from Amazon. We have Control Tower and Security Hub. So even if you're not a large regulated organization, you can build account structures such as these. So anyone can build these now. The power to build these account structures has been placed in everybody's hands. So what we're going to focus on right now is this final element of cost control. We want to make sure that we have an automated mechanism for managing spend before we hand these learning environments off for your developers and users to do self-guided learning. So how are we going to achieve this? Let's have a look at a solution architecture. So I'm introducing the concept of a provisioning account here. Now, I've just diagrammed it. This is an example. I've got an API gateway and a provisioning Lambda, which is going to do all the work here. But it doesn't have to be this particular structure. We can drive this out of ServiceNow or any other organization-wide config manager or workflow engine that you might have in place. So our user is making a request. They're hitting our provisioning endpoint. They're saying, please give me my own environment. I want to do some self-guided learning. So our Lambda is going to fire. It's going to build up a standard account baseline. So I'm not going to fill this box with all the icons for all the standard compliance and controls. We're going to build that account up according to the process and the structures that I outlined earlier. So in addition to all that, what we're going to do is automatically provision an AWS budget. So AWS Budgets is a pretty cool little tool. We can load that into our account, and we can configure that with a certain spend. So in this particular case, I've configured $100 of spend against that account for my developer to use as they see fit. So budgets will keep track of our spend, and there's a lot of flexibility here. Budgets can give us warnings as we approach our threshold. It can also be configured on a dollar spend or a percentage trend. So now we have a self-guided learning environment that we can hand over to our developer, and they're going to start using that account. Maybe they're going to run through some workshops or some exercises. They're going to start standing up resources. So the really nice thing about that is we've actually built a feedback loop, because as that developer starts experimenting with new services, they're going to start getting budget alerts. They're actually going to see that their budget has been consumed in fairly close to real time, and they'll start to get a feel for how particular services impact upon your spend. And that in and of itself is going to make them a better developer. So at some point in time, we're going to run out of money. So the budget is exhausted, it's gone to zero. And at this point in time, AWS Budgets is going to fire off a notification. It's going to fire a notification to our budget exceeded SNS topic. And we've chosen to wire that up to a Lambda again. So the first thing that our Lambda is going to do is going to suspend access to the account. Next, we're probably going to schedule some activities. We're going to maybe snapshot some data inside that account, capture the learnings. We are going to schedule this account for deprovisioning. So this is an ephemeral account. It's going to go away at some point in time. So I think this is all pretty nice. This is all pretty cool. But what can we do with this? Because it's probably not so much about the technology. This story isn't really about the technology. So what can you do to help your people on their self-guided learning journey? So let's think about the idea of budgets a little bit differently. So rather than thinking of it as being purely a cost control measure, let's talk about it in terms of investment. So everybody in my team gets an innovation credit. So perhaps you get $100 a month or whatever for you to go off and engage in your cloud journey. But I think we can make further use of that. So perhaps in the context of a game day or an innovation day or a hackathon, we can actually pool our innovation credits. We can encourage and guide our users. We can give them a challenge, form a team, pool your credits, solve problems, work together and gain increased knowledge of AWS. So I think the technology and the process together is actually quite a powerful way, not just to upskill your people, but empower them as well. So that's the end of the first pattern. The second pattern we'd like to talk about is working with data. And for that pattern, I'm going to hand over to my colleague. Thank you, Kevin.
Thank you, Ian. Okay, so having enabled our developers with accounts, we've given them a space to try things out. We're going to turn our attention to the data you've got in your system. So how can we give them access to production-like data to really play around and see what they can do? And I guess a reasonable first question is, why would we do that? What are we trying to gain out of this? So there's a number of different things that we can get by giving developers access to production-like data or realistic data. We reduce errors and share knowledge, so we enable developers to understand their production systems more effectively. We remove bottlenecks, so often test data management is a big thorny problem, and in a traditional environment, often you'll have very large databases, production data, very slow processes to take that data, mask it or filter it or otherwise make it useful in a non-production environment and then feed it out to people. So we think we can do better than that. We can unlock some extra value from what you've already got in AWS. Yeah, hopefully enable the developers a bit more. So we want to provide developers with compliant production-like data. In a pre-cloud environment, as I say, in an on-premise type environment, this can often be very difficult. You'll have a heavily protected production data store. Your compliance burdens mean that feeding that data out and masking it effectively is a slow process. In AWS, we've got a bit more flexibility because we've got the ability to stand up and tear down infrastructure, to automate things. We can replicate data, we can modify it, we can have it exist in multiple locations. We don't have big process overheads. So for this to work really well, the two things that are really critical are the masking itself, so making sure that you've got the masking right, and the speed, the latency between your production environment and your non-production environment. So how quickly can we get the data from a production space masked through to the developers so that they're understanding how their systems are working? So onto the pattern. We assume here to start with a production database in AWS. You've got sensitive data in there, PII data, sorts of things that you really need to keep in production. You're running snapshots on this, probably nightly, whatever frequency you're doing that at. What we're going to suggest is take those snapshots, stand up some new infrastructure in production. So this is all done within the confines of the production environment. So you've got all the standard safeguards in place. So we take the snapshot of your data, stand it up in a brand new replica of your production database. We then use AWS Glue, and Glue is essentially an ETL layer, extract, transform, load layer. It allows you to script up tasks in Scala or Python. It's highly customizable, but it's basically designed to take data out of a database, apply a transformation to that data, load it into another one. And what we're going to use it for is defining the masking that needs to happen on your production database to make the data safe for developer consumption. So the entire pipeline here is automated, it's scheduled, it runs without manual interference and without impact to your production databases. Because we're operating off a snapshot, we're not touching the production database, we don't have any performance issues. So stand up the replica, run Glue, do your transforms, mask your data, push all that into a non-sensitive data store still in production, snapshot that, and tear down everything that you just stood up. So we take away all of the resources that we were using. We're not paying for them anymore. We don't need them. We now have anonymized or desensitized snapshots that we can make available to developers. And at this point, we cross that production boundary. So we can take published snapshots. We can make them available to developer teams within your organization. You've got standard IAM controls over that, so you can link that into whatever authorization processes you have already. It's all automated and it's all self-service, so it allows for the centralized management of the masking rules, so you can assure as a production team that the data is being appropriately masked before it's available to people, but then self-service of the use of that data into the development spaces. Which means people don't have to come to you and say, please, can I have a look at your data? If you've masked it, put it there, they can go for their lives. This approach is really good for large traditional data sets. It provides development teams with a regular access to production-like data to use as test targets. How can we take this further? What else can we do with this? So once we've got this system in place, it enables a few other interesting things. So once you've got an automated pipeline like that, you don't need to run one. We can make modifications to that and run several of them. So we can do data that's heavily masked but a complete data set. We can do cut down snapshots if you want faster testing against production-like systems. We can do uplift from on-premise. I didn't mention it, but Glue will actually run against on-premise databases. So you can take an on-premise database, push it through Glue out into AWS and let your developers work on AWS environments with on-prem production data. It's a massively useful tool for migrations. You can trigger provisioning because Glue's such a customizable product. If you have an environment that's not just, here's a snapshot of my data stood up and I can test, you have a whole bunch of integrated systems that need to have similar state to all match in. It's fairly common for shared integrated test environments. You can trigger the provisioning into those extra systems to build an entire testing environment. Completely automated, completely repeatable. Overnight, batch analytics, warehousing, all those sorts of things. So all these scenarios are enabled by having that silo of data. I'm going to move on to pattern 3. I'm going to hand back to Ian to...
Thanks, Kevin. Thank you. Okay, so we saw how to enable self-guided learning in a safe manner, and we talked about some ways we can actually feed our structured data back to our development team so they get a feel for real-world data, but in a safe and compliant manner. So now we'd like to talk about real-time data. So we want to talk about enabling analytics, and we also want to talk about enabling visibility of our production systems, but always making sure to do that in a secure and compliant way. So once again, why? Why do we want to do this? What are the benefits? So there's quite a few reasons for this. So number one is improved visibility. I know as a developer, the better I understand a system, the better I can write and support and evolve that system. So if I have a safe way of giving my development teams visibility into the operations of my production system, I'm going to be able to do a better job of actually writing for that system. So the second reason I think is one of the more interesting ones. There's a really rich ecosystem of analytics providers out there. And to some degree, it's been difficult to make use of them with highly compliant data. There's always a concern and a risk of sharing your data with a third-party provider or even an in-house analytics provider, or letting that data cross your production boundary at all. The third reason, real-time compliance. So perhaps if we stop thinking about this as perhaps a post-fact event, maybe this is something we bake in at the actual design level of application, so that all my applications by default are emitting event data in a compliant manner. And finally, there's some potential here to make more use, to get more leverage and benefit out of our data. So we can transform and manipulate this data and make it suitable for different consumption purposes. So we want to enable a near real-time stream, but only of the relevant, only of the safe production data. So I'm going to hand over back to Kevin, and we're going to demonstrate this, what this looks like.
So we can go over to the live demo.
Thank you very much.
So this is the live demo section. Wish me luck.
This is not pre-recorded. This is live.
So I want to start by talking about the architecture a little bit. So what we've got up here, standard sort of architecture. You're looking at a very standard web application up front. So you've got users doing things inside the system, generating data in a database. In this demo, we've actually rolled that out as an S3 static website, DynamoDB, and submitting transactions. That's kind of the standard bit. You'll have a whole bunch of those sorts of applications throughout your environment. What we do with that is we say, okay, we've got this data store, we've got this source of information. We're going to pull those out as events. We're going to feed them through a real-time filter. And in the demo, we're implementing that as basically a Lambda. DynamoDB streams off the back of the database. And then we're going to feed it out, spread it out to a number of different consumers. So I will talk a little bit about the technology, but it's worth calling out the technology choices are not the really critical things here. So we've implemented the demo using a particular set of technologies, DynamoDB, streams, Lambda. The crux of it is actually the pattern, not the technology. And we want to keep in mind what we're trying to achieve all the way through here. So we're trying to get a sanitized stream of near real-time data that can be consumed by a number of different people without having the massive regulatory headaches. So let's wrap a little bit of a story around this. You've got a product team. They've come up with a wonderful new idea. It's going to make you millions. They've gone and got themselves a development team, stood up an application, and they're out live selling whatever it is they're selling. We'll go with widgets. So the system's up there, it's live, it's doing traffic, it's hopefully selling lots of whatever it is it's selling. It's now generating a lot of data, and that data can be really rich data, but it's production data. We focus on a couple of different types in particular. So we've got the obvious transactional data, so this person bought this thing at this time. We also have the developer relevant data, so things like debug logs, tracebacks, the sort of information that your application developers are going to care about. Now, in this demo, we're treating all of the sources of data as the same. We're piping them all through as one stream of data. But it raises an interesting point. When you start building a filter system like this, you've got some design decisions that you can make, and to some extent they're dependent on the structure of your organization and how you want to address these problems. So we could, for instance, build masking that is very specific. So we could say, here's a stream of data, we know exactly what that data looks like, we're going to mask it in exactly this way. Or we could widen it out a little bit and say, here's an application, we're going to pipe all of the data from that application through a generic system that understands some of the data and knows the critical bits to mask, but he's also applying some generic masking rules. So we're just looking for patterns and saying, oh, that looks like a credit card, we'll X that out. Or you could go whole hog, go completely completely the other way and say, we're going to build a masking system that is essentially an enterprise-wide masking service. All of our applications can plug into it. It's going to analyze all the data going through and mask anything it thinks is appropriate. For the demo, we've kind of taken the middle path there, and I think that's probably a sensible one, but it very much depends on your organizational structure. As with any sort of software architecture, organization software tend to be very linked. So, excuse me. So we have the system up and running. People can purchase things, make payments.
That's actually my credit card number.
If people want to take a photo of that one. As the system's running, we've got logs going into CloudWatch. We've got data going into DynamoDB. And if I've set this up right, I can hit search and show you.
Oh, the risk of live demos.
Yeah. I'll tell you what, I'll go back to a previous one. So this is the sort of thing we've got in the database. And you can see it's got some fairly sensitive information in it, right? We've got credit card numbers, we've got CCVs. Whether this is the specific data you're looking at or not, your production databases are full of this sort of really sensitive data that you don't want to let out. Because the data's there, but it's not really accessible. It's difficult to navigate in production. You can't, in a regulated environment, give your developers full access to it. You can't give your product people, your analytics people, full access to this data. A traditional answer for masking might be that you dump all this out to a log on a file system or out to S3, run a batch masking process similar to the glue pattern that we did earlier. But we think we can do a little bit better than that. So, we go back to the architecture. What we have here is, off the back of the database, we're pulling a stream of events, and we're pushing that through a filtering system on the spot. The filtering system can be reasonably simple or reasonably complex, and I'll talk a little bit about that later. The targets for those outputs are actually a really interesting thing. So, you have a decision point to make here on how you implement this, and what I would recommend is we take a compliance level approach, not a consumer approach. So when we look at these data stores out the right-hand side there, the data store, the analytics, the microservices, the feeds that are coming out of your system ideally are not tailored to specific consumers. You don't want to put your product team in a position where if somebody wants data from the system, they come and say, please, I want this sort of data in this format, in this way. And you have to build something new. So you ideally have these generic feeds of data that are at appropriate compliance levels. Anybody can self-service onto them to use them. So Ian's just pointing out the time. I will nudge forward a little bit on this and show you. So because we had built this demo in that way, so we've got a very generic feed, we were able fairly late in the piece to go, oh, look, we don't have a great visual on this. Let's grab a SaaS product off the shelf. And we've gone with Datadog, plug this in, and just see what we can show out of here. And now, because that other one didn't go through, I'm just going to widen that out. So you can see the events coming through here, and you can see that after they've gone through the filter, we've got credit cards X'd out. Our filter looks for CCVs as well. It's actually looking for 3 digits in a row. If it sees that by itself, just X's them out. So what we're enabling here, and the real power in this is once you've built that compliance right down deep into your system, once you go to the definition of done for your product and say you need to have sanitized, cleaned, compliant data coming out of the system. Once you've got that, you enable a whole bunch of other flow-on activities. And we talk about the changes in behavior across a couple of different things. You can enable a more DevOps mentality for your developers. So you can give your developers access to very nearly production data. They can see the system operating in real time. They can really understand how it's working. You can give this data to your analytics people so they can be doing A/B testing in real time and actually analyzing the behavior of the system as it's happening. You can open up the doors a little bit, and this is something that's often hard to do in a regulated space. You can open up the doors a little bit for using some of these SaaS products. So we can go out and say Datadog or whatever the products are out there, and analytics especially. There's a rich ecosystem of new tools and technologies out there that are often an individual product team will have trouble onboarding because they'll have to go through a whole process with regards to their data. We can make that a lot easier. So the other things to note, receipt of data is near immediate. The way this is set up, the events go into the system as we submit. The event flows straight through the system and is out the other end as masked data within a second, typically. The filtering itself is scaling. We're using AWS native technology, so we're using Lambda, we're using SNS. These things scale naturally. Your production team, your product team doesn't have to worry too much about that. Your organization can self-service onto these streams once you've got them in place. Again, you're using IAM and identity management to allow people to self-service on. So lots of different use cases. I'll cut it a little bit short because we're down to
Really
literally
out of
seconds. If people do build something like this and come up with some interesting use cases, though, I would love to hear about them. So
Thank you.
pass back to Ian.
Can we come back to our slides? So let's wrap up.
Yeah.
Okay. So let's cut it short. Final recap. So highly regulated environments, they pose specific challenges, but we have the tooling available to us on AWS to help with that. So quick review. Firstly, enabling self-directed learning at scale while still managing your costs. We talked about how you can flip that around and use it as an investment in your people for them to take the next steps on their cloud journey. Secondly, we talked about a cloud-native approach to managing structured data. We can replicate it, we can transform it, we can empower your development teams to work in a more realistic environment. And finally, we talked about managing real-time data. So you can also make use of that. You can leverage that for analytics, for developer understanding, for marketing and development purposes, and remain safe and compliant. So that's the end of our talk. Thank you so much for attending. And if there's anything you'd like to hear more about, please come visit us at the booth. Thank you.